Hello there and welcome to our video on performance in extreme environments. We're here to find out more about the effects of altitude on physical activity. We wanted to know how it can affect performance, how athletes can use it for preparation, and also how you can use it here in the UK.
So, we headed to the Sport, Exercise and Rehabilitation Sciences School at the University of Birmingham to conduct some research and also to interview lecturer and researcher Sam Lucas.
At altitude, the air is thinner, but there's a common misconception that this means there's less O2 in the air. However, this isn't the case. At altitude, there's the same amount of oxygen in the air, but the partial pressure of it's a lot lower. This is because there's a much greater space between each particle, so the pressure up here is a lot lower than it would be down there. This means that every breath you take at altitude, you take in less oxygen than you would at sea level. This is why aerobic exercise is a lot harder at altitude. Now you may notice there I said aerobic exercise specifically. This is because a lack of oxygen has no real effect on anaerobic exercise. So performance at altitude will affect endurance athletes a lot more than it will affect sprinters. Here's an animation to further explain.
As the person gets higher up the mountain, the oxygen particles become more spread out, meaning a lower partial pressure and less O2 per breath. The reason this affects aerobic athletes more is because aerobic work relies on a continuous supply of oxygen. If this supply is lessened, the muscles will have smaller supply of O2 to work with and therefore fatigue quicker. Believe it or not, Sam Lucas told us that altitude actually makes anaerobic work easier, as the spaced out particles means less air resistance, allowing movements such as sprinting to happen with much less resistance than at sea level.
As you can see on this table showing the Mexico Olympic track results, any events that are anaerobic actually show an improved time compared to that of 4 years earlier. This is due to the lower air pressure providing less resistance at altitude. Anything longer than 1500 metres has a slower time. This is due to the lower partial pressure of the oxygen at this altitude.
Whilst altitude hinders aerobic performances, it is actually used during training to improve them. We spoke to senior lecturer Sam Lucas about his studies on altitude training. He had athletes from the UK living in a sleep hotel for 4 weeks. The hotel for this study was at sea level, but had the technology to replicate altitude. This meant that they would live in altitude conditions and then could train at normal level. The altitude chosen for this study was 5,000 metres. This is a very extreme height to be at. There were two groups for this. One would sleep at altitude and train at sea level. The other would both train and sleep at sea level. This live high, train low study was a gold standard, and yet the results weren't convincing. This method worked for some athletes but not for others, and it's yet to be fully proven for the whole population. Perhaps this is something you could look to study at this university in the future. So the science behind live high, train low is that living at high altitude can elicit an increase in red blood cell count. This would increase our VO2 max and then in turn increase our aerobic performance at sea level. Whilst the live high, train low theory is yet to be fully proven and backed up, high altitude training alone is an effective method used by athletes such as the GB rowing team. They have a high altitude camp in Sierra Nevada in Spain at 3,500 metres. This is to improve their cardiovascular fitness.
Altitude training is very effective, but may seem slightly inaccessible for the wider population. This, however, isn't the case. When speaking to senior lecturer Sam Lucas, he gave many examples of how you can simulate altitude here in the UK.
So the first of these is the altitude chamber. We're actually lucky enough to have one of these here at the university. It works by either changing the pressure in the chamber or by reducing the oxygen content. It's currently being used by students for their studies, but is also available for athletes to rent. So he also spoke to us about hypoxic tents. These are airtight tents that restrict oxygen flow. They can be placed on our beds and we can sleep in them. They're used by endurance athletes such as Mo Farah. So finally we have oxygen masks. These restrict airflow and so can replicate exercise at altitude. You can even see people using these in the gym.
There you have it. Now you know how altitude affects performance, how athletes use it for preparation, and how available it is for UK athletes. Thanks for watching.